Hello and welcome to day 18. Today we will, let us look at the outline for today as we always do. So today we will take a look at an introduction to classes. We will not go so deep into what classes are and all the advanced functionalities. We just introduce ourselves to it, some of the basic concepts we have to know. So what is even a class? Well, uh, in the simplest of terms, the class is a blueprint of an object. So it is not the object itself, so it's just a blueprint of it. So you can think of it like getting together all the blueprints of a building. So you get to see that, okay, this is how the building will look like, or this represents the building, but not the building itself. It is like a car that has been modeled with a software. It has not been built. The model itself is like a blueprint of how the car will look like. So yes, that is a class. So the blueprint of an object. Which object? Any object. So any object at all, you can create a class for it, so a blueprint for it. So an object like a person, a car, anything you can think of, as long as you can write it in code, you can create a blueprint for that particular object. Okay, so let us go into Python and see how all of these things come in. Okay, so I have my file created in advance as always. And so how do we define classes in Python? Well, so we just use the class keyword like this, precedes everything with the class keyword, and then the name of your class will follow. So if it is my class, we terminate this with a colon, and then maybe let's say pass for now. If we pass, and then this becomes our class, what we call the blueprint. So if I should give this thing a proper name or any real name of anything in the world, that becomes the blueprint for that. And so here is where we can store all the attributes, and then that is the particular data or data that is specific to that particular object or information, or any attribute that is specific to that. And then the methods, that is a technical term, which also looks at the functionalities that can operate on that particular object or data. So if you take maybe a class like that of a car, what are some of the functionalities of a car? Maybe accelerate, decelerate, and all of those ones. So this is how we create a class in the simple term. I don't think I've introduced you to this pass keyword, but if you don't want to do anything in a function, I think a loop, I've not tried for loops. Let me see. For I in range 10, I think it will allow me to pass. So the pass does means that you are not doing anything, but you don't want to get an error when you run your code. Because if I don't put anything here, chances are that I'll get into an error when I run my code. So after we create the class, how do we get access to it also? So in that case, we say we are instantiating the class. Instantiating the class. Let me try and type the word. Instantiating. I just hope I'm right. So that means creating an instance of the class. So an instance of it. An instance is maybe now I have a car model. Like let me use the car example for now. I have a model of a car designed for a particular car company. So that is the blueprint. So if the company takes my blueprint and creates maybe a car, my model, I chose the default color to be a white, and then they create the same car with my model and then gives it a red color. The physical red car becomes an instance of my blueprint model, my car model. Yeah. So if you create an instance of it, or like that is it, it's an instance. I don't know which word to use, not to sound too technical. So I can say maybe my class instance. Forgive me if these variables don't make sense for now. You get to understand it better. And then I can call my class. just like this. And so if I print my class instance, let us see what I will get. Okay, so it tells us that main class object, and then what follows this one here is a memory address. The one that is preceded by the 0x is a memory address. That means somewhere on your random access memory or your RAM, this is where the class is stored. I told you earlier on that everything that we are doing here is using the memory of the computer. So this is the memory address. And then this is the name of the class. So we know that whatever thing that we printed to the terminal, which is my class instance, is an instance of this class object. So that is it about the basic implementation of a class and also creating an instance of the class. So we can look at more complex examples. So if I have, let's say, a person class, so let me get rid of everything here and then create a class of a sales employee, but I will not take it. Person like this. This time around, I will not pass like I did because now I want to give in some attributes, some things that describe a person. And so I want you to remember this particular, um, a little cryptic, like everything we've seen, more than anything we've seen before up to now. That is the innate method. You see me, we have used def for this, but if it is a function outside a class, we call it a function. But if it's a function inside a class, we call it, I don't think I want to type it here. We call it a method. So please take note of this. If it is inside the class, it's a function. If it is outside the class, sorry, it is a function. If it is inside the class, it becomes a method of that class. So yeah, so I'll be saying method instead of function, so don't just get confused. So this is the person. Now, whenever we create a person, there are some things that should be basic. This self parameter, make sure that you always pass it. It just refers to the class itself. So it is a requirement you have to pass. You have to pass it. At least for class methods like this, we are not also getting deep into static methods and all those ones, but static methods and class methods. But just know that for this, you have to pass it in. For other class methods, you may not have to pass in self. For class methods like this, you have to pass in the class, so maybe CLS. And then for static methods, you may not have to pass it in at all. But you may not get the, maybe you can explore further by taking this thing further. But this session is just to introduce you to classes. And I want you to know that for now, if you create any class method, you have to bring in self as the first parameter. And also this name here, you see underscore underscore, innate underscore underscore. It's not a function name that I brought up from my mind. No, it is standard, should I say a standard function or a standard method in Python. There are other ones like once you type def and then underscore underscore, you see that Python suggests them for you. So there's the str, which gives the string representation of the class or the object. There's dir and whole lot of them. If you want to use any of these, there are special methods. You can't, it is not your own. So just type the name just as it is. Well, think of this innate method like what initializes the class, like in the simplest of definitions, uh, not to sound so technical too. So you see here, they say the base class of the class hierarchy. It's just trying to confuse us. When called, it accepts no arguments, but take it like this is what initializes the class. So just use init and then map it to initialize in your mind. So when we initialize our class, so to speak, what do we want to get? We want to get the person's name and maybe the person's age. So this is our blueprint for a person. If you want to create any person in our code, this will be the blueprint. So now that we have this one like this, what can we do with it? Okay, after passing in the parameters like this, you see that I have some squiggly underlined there. Let's see what PyCharm is saying. It says parameter name value is not used. That is not even what we are worried about here now. My focus is on the yellow one that says add field name, add field name to class person. Okay. So what does it mean by we should add the field name, the field which is called name to the class person? Why we have already passed it in here, so why do we have to add it? Well, it turns out that after you pass it in here like this, you have to initialize it also, like uh, less technically initialize it. So I'll have to say self dot, then I give a name here. So usually by convention, it should be the same thing. But you can say maybe self dot something now maps to name. So you have to initialize, add should I say class, these are not class variables, but a class field as the IntelliSense suggested, that maps to name. So if I now want to say, I think I may get ahead of myself a little bit, and then I'll say return self dot something. So this underscore string should be able to return, like when we print something to the terminal, it should be able to tell us in proper terms instead of the memory address that we saw. So maybe I'll pass in age to maybe John's age is 25. And if I print person, you see that I got John. So that means this method is the one being called. At first, when we did not have the str method, when we printed it, we only got, if I comment it out, we only get a memory address like that. But if you have the str method, whatever we return inside the str method is what will be shown to the user. So that makes it more readable and useful also. Let me monitor the comments. Okay, no comments. So that makes it more readable and useful. So maybe for readability's sake, let's just leave this method untouched for now. It's also a special method. You can see it comes with the underscore underscore. So this something here is mapping to this name parameter that we are passing here. But as I told you, by convention, you will not see something like this. It is bad practice. You will not see any seasoned developer out there doing something like this. So unless in special cases that you have to do so. So usually you see self.name equal to name. That doesn't mean that compulsorily you have to make this one and this one and this one. I don't know whether you see what I'm referring to. Doesn't mean that you have to make this one and this one and this one all the same name. No, 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 no. In any case, whether you choose to give it the same name at this side, no, at this side or not, these two must always be the same because you are mapping what is at the left side here to what is at the right side here. So that is it. So now I can map again self dot age because I want to follow international best practices. So self dot age equal to age. Okay, so that becomes the blueprint for a person. Now, when we create any person, we can create multiple persons. So person one, that should be equal to person, or not John again, maybe Jane this time around, who is 24. I can create multiple persons. So I just have one blueprint, but I've created two instances out of it. And I can work on each of these instances separately, like differently. So let's just say I want to create a function that greets John. So I can say ref greets John, and which will take in the name. And then I'll say print is a special greeting for John. Oh, no, 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 not for. Uh, I don't have to pass this one in here. Or maybe I should, because this is only for John. Or, but still, let me pass it in here. Name. Okay, this one have to be an F string, and I here can say name equal to person dot name. Sorry, dot name. And that is also to say that if I want to access the name of or any of these parameters or fields I have passed here, these fields here, because when we call the dot is this what renders what will be returned to us is what is inside the init. So this person dot name will return this line. Yep. So if I pass in person dot name, I will not see it because I've not called the function. So now let me call bit John. I don't have to pass in name because I have made it a default parameter. And then this is a special greeting for John. And then we can go ahead and create another special greeting for Jane. So that I'm just trying to show you that when we create a blueprint, which is a class, all the instances that we create out of that class, we can use them separately, independently of each other. This one here can be used differently than this one, and it doesn't cause any problem or confusion with Python. That is because the class is just a blueprint, and then once you create the object, you can use it anyhow, anyway. And so maybe you are wondering why will I even create a class? Well, in most cases, sometimes maybe for in advanced or maybe in intermediate development, you will need to create classes. There's one of my YouTube videos that is on the channel, and I taught how to create a paint application with Python. And so I had to, the package that I was using did not have anything called, let's say, drawing canvas, where which I can just call and insert into my code. No, it didn't, it was not there. So I had to use the base class widget. They choose to represent everything, every component by the name of, like every component is a widget. So what I did was I found out that there's a base widget class. So I took that base widget class and did something with object-oriented programming or with classes called inheritance. So I inherited from the base object class and created my custom canvas for my project. So you can also inherit from this one. Maybe today we will get there, maybe we will not get the class inheritance. You can inherit from this and extend it in any way that you want. So that is the beauty of object-oriented programming. You are able to create blueprint for every object, any object imaginable. So that means that if your organization or you are building for an organization, you can create objects or classes that are specific to the functionalities of that organization, because even the creators of the packages or Python itself cannot write code that will cater for every need of every person in the world. No, that is not possible, because even what we need to do keeps changing by the day. But if you have an object-oriented programming language like Python, you can create objects for whatever thing that you want to do. So maybe let me get rid of all these grid John things for now, and then let's see how we can take these things a little bit further. So you also know that if I want to access maybe a field inside my class, I can now say that maybe name of person one. Because that is what I want to access. So person one, that should be equal to person one dot name. Sorry, I keep on. Okay. Now, if I print this name of person one, I should see Jane there and not John. Okay, so in here, you've seen the dot notation that I use it to access a field inside the init. Okay, we can use it to do more. So if we want to create a method or a functionality that relates to a person, we can do that too. So maybe we can say define, and this one will not be with underscores. It's my own method. So that will be define work. And always, as I told you, you should make self the parameter. Even if you are not given any other parameters, self should be there by default. Okay, except for class methods and static methods, which you may be exempted from that rule. But other than that, the self should be there. And so I can say now print inside an F string, I will say now self dot name is working. So let's see how we can get each of these people to work. And I can get rid of this and then say person one or person dot work. And now you see that if we even type person dot PyCharm, or let me say any intelligent editor will do this for you, automatically picks all the attributes, all the methods. You see, there's a small f. We don't have attributes yet. I don't know whether you see my f. It should be grayed out. But that is a field of the class. So it's inside the initials, the field. And there's one M here, which is there for method, as I talked to you before. So once we type dot, you see all the methods listed here. So it's just like when we're using lists, you just type maybe the list dots, and you see a lot of things pop up. Probably inside the main Python built-ins.py are a lot of classes. So once you hit the class, like the class of a list, you access all the fields and methods that are available in there. So person1.work, person.work, and person1.work, person1.work, and let's see. So when we run our code now, we see John is working, and then Jane is also working. So that is what we wanted this to do. And then maybe we can say grow, a function for grow. So define grow. It is self. We are not taking anything here. Okay, we will take one more thing here. So grow, and then here we want to take by how many years should the person grow? So maybe we can say year or years, something like that. Okay. And then in here we can say self plus self.h, sorry, plus equal to, you know, the syntax already. So that means that we are taking the current age of the person and adding years to it. So plus years. And then let's create another method that will get us the person's age. Okay, we don't even actually need a method. We can just do by the field name. But let's, instead of returning just self.name, let's modify this one into an F string. So self.name, I just want to put the name and the age all at once. So name equal to self.name. And then now age is self.age. Okay, so now when we print the person, we should see the person's name and age. And I think, okay, we have not initialized the age. So let's see what will happen. Let's just print person one, person two, and see. So print, or we can just print person for the time being. We didn't initialize the age. Let's see what will happen. Okay. It said 20. Okay, okay, sorry. It is here. Sorry. I was thinking it should be put here or something like that. We can do that also, but I forgot that when we called, we placed it there. So that is great. So now that we know that the person one's age is 25, let's just say now person one. Sorry, I keep on saying person one instead of referring to person. Person dot grow, and in here I now have to pass in years. But let me pass 5. Watch it. There are two parameters in there. You let me print now. Let me print person again and see. Print person. Something has happened. In fact, the code ran successfully, but I didn't get a particular error. The first time that we printed person, this place, where was it? Yes, this place, the person's age was 25, what we initialized it with. So that was John's age. And we said person.grow maybe by 5. And then John's age is now 30. But if you look at the grow method here, you see that there is first self before years. But I didn't pass anything for the self. Yes, you don't have to. And that is because you don't have to. Because the self there refers to this person instance. So you don't have to. You don't have to say self is equal to something. No. That one is always there by default. It refers to the class itself, or the instance of the class, in this case itself. So when you if I delete the age from there now and I zoom in, when I put my excuse me, my cursor on it says parameter years on field. So it's not really bothered even about the self, it's the year. So please don't pass in things for self, except in some special cases where we do that. But for now, just don't pass in anything for self. In this basic example, and in most of the cases that you see, you don't have to pass it in. So can maybe say years equal to this time around 10. So I'm expecting John to be 35. Okay, so that is it about it. I don't know which other method we can add to the person class, but I hope this also give you a very brief overview of what classes are and how we can actually use them. Or maybe we should think of another method for the class, and what will it be? Okay, let's hold it here for now and then go on to another example for the sake of diversity. So let us now look at another example with the classes, but this time around with a completely different object. So we leave our class here like this. And then now let me see a class of, say, circle. We are defining a class for the circle object. So the ordinary circle in geometry. So you know that I have to go with my define underscore init. You know that one already. And then in here, you know what I have to take is the radius of the circle. And so here I can, I have to initialize it here, that self dot radius. I can choose anything here as you saw in the first example, but it is best practice to do this. So self dot radius is equal to radius. It's just a mapping to the radius parameter. So I can get rid of these ones here for now. Okay, so this is the circle. And maybe let's say you have been given an assignment, or maybe this particular thing I'm saying, let me hold on to it and I'll say it later on. And so here we know that we can compute first the area. So my tab. define area, and then we will pass on this for now. Instead of the pass, I can also use this three dots. Python understands that one also. I also want to define perimeter, like it has suggested. Um, what else can we compute on circles? I think the two will do. I think I've forgotten my mathematics a little bit on the area of a circle and perimeter. Let me do a quick search of the formula online. The area I know is the pi times the radius squared, but the perimeter. Okay, 2 times of pi times the radius. Okay, so that will also do. Yep. Okay, so if I want to compute the area, I need pi, which we don't have now, times the radius squared. But because pi is something that we'll be using almost at every place, now if I document this, I don't think I introduced you to this, but we mostly use it in methods or functions. So this doc strings that you see me use here, you can use it for documentation actually. So if I say here that returns the area of the circle, sorry, circle, that's all. And then here in the return, I can put area of the circle, area circle. And now, without doing anything, let me show you what that thing that I just typed with the return statement will be. So, sorry, circle equal to circle. And here I can say I have to pass in one thing here, which is the radius. Maybe let's say it's 4. And then I can now say circle dot area. When I put my cursor on area, the documentation that I just gave will pop up. So you see here that what I typed in there is in here. And so it says, and also the return value, we know that it returns the area of the circle. But if I do for perimeter, when I hover over it, we will not see anything, no documentation. Just telling us that perimeter is a method of the class circle. So as good practice, you always have to give this documentation when you write methods inside classes so that people will know what exactly you are returning. And if I also want to be more technical, I can, you see, now when I hover over it here, back to area, it says it returns none, which is not true because what we plan to do is to return an integer, which is the a double. Sorry, double is in other languages like C++. I'm sorry, a float, which is the area of the circle. So the syntax to do that in Python is this. If you are coming from other languages, I think R, this might mean something else, but here in Python we use it to tell what things or what type will be returned. So here it will be float. So if I modify my function to look like this, then now it will not tell me that it returns none. It will tell me that it returns a float. So I know that the output of that will be a float. That is useful in the case where the return from that particular class method will be used in other places for other computations. So it works best like that. Okay, so we need a parameter called self. Though after that, I can do this thing here. So I can say area, but I can return it straightforward like you saw Python suggested. So I can return self dot radius, self dot radius times radius, but I want to organize it well. So area, maybe area of circle equal to, it's suggesting that I use math.py, but I will not do that. I will return self.radius multiplied by self.radius. The reason why I did not accept the math.py is that I want to show you what we call class variables. So, okay, it says expected float, but got no return. So now we can return the area of the circle. So I want to introduce you to what we call the class variable. That is, if you have a variable or a parameter or any value that should be used throughout the class, or it's very common, all of them, all the methods can use it. Like in this case, pi, I can declare it before the init like this. So I can say pi, which I like to capitalize. I'll not take this suggestion, but I will import it from math. I need to import math at the top. So import math, which is also another package in Python for mathematical stuff. So math dot, is it pi? Yes. So this one will return the value for pi. So this is also a little bit intentional. Forgive me. Forgive me for that one. Not this one I'm about to say. I'm feeling a little uncomfortable. I don't know why. This math.py, you saw that we called circle.area. And if I can actually also call maybe circle.radius, and you know that. So radius, and you know that. And that will return the radius of the particular instance of the circle class. And so I'm using math.py here, which will also throw some, which will also tell us that fine, it means that this pi that we have created here, or this math that we have here, may be an instance of a particular class, which has a field called pi, that when we now say, or maybe a method called pi, that when we now say math.py returns the value, the mathematical value of pi. So let me be a little curious, control or command and click on math. And then I see here that I'm in a file called math.py. Please don't modify this code unless you know exactly what you are doing. And then I see the variables here. And then you see that that is the value for pi stored inside there that I am assessing. So that's all the beauty of that. But I don't think this one was even a class. No, it's just the file. But in any case, if it was a class, we could have done that. But that is also, I was just trying to use that one to explain. It's not all instances that you see dot that means that it's a class. If we have another file, like when we did the modularization, we were able to call dots, and then what was it we were doing? To do's. Yeah, we were able to call the dot to do's from that file. It was not a class, it was just a module. So we want to use math.py also here. So here we can say math, sorry, pi, because I've already declared it up there, multiplied by this. And it's here saying that it doesn't know pi. What is this? Unresolved reference pi and xml.e3.py. What is it trying to import for us? Let me see. Okay. I forgot the self. Sorry, it's also still a class variable. So self.py. Sorry, self.py. So now if we have this our circle here, we can actually see now print. Sorry, print circle dot area. We run, we see this, and we trust Python that the computation is correct. Okay, there are floats in there, so that will make manual computation a bit difficult. But if you change this one for a moment and say 3, just to test the output, whether it is correct, that will be 3 times 4 times 4. That would be 16 times 3. That should give us 48. Okay, so let's just run it now and see. Okay, that gives us 48. Great. So we know that it is working. Let's go back to our math.py. Okay, so now we have this area method. Now we can also work on the perimeter. So maybe we can also give a documentation, proper documentation here. So returns the perimeter of the circle. And we can also modify this one a bit to give the return type, which is also a float. It will return then perimeter. If this documentation confuses you, don't worry. You can skip it. It's not compulsory. But if you can give it, anybody who is reading your code will know that you are a seasoned developer. So here too, I can say perimeter of the the circle. And we set that one to be equal to let me check the formula again. 2 times pi, so 2 times of self dot pi times the radius, so multiplied by the radius. Self dot radius. Please don't be forgetting these things. Other than that, you get into error. But I want to be safe, so I'll wrap this one in parentheses. You can skip that. That is not really a strict requirement. But usually when you are typing formula, you want to define the order of the operation by using parentheses. Other than that, that rule of BODMAS will apply. So now we can say perimeter of the circle. And so here we can also say, maybe not just print circle area, maybe print the area of the circle is, and then I can pass this one in here and duplicate this line by Control D. If on Mac, it's a Command D, and the perimeter. If we are using Visual Studio Code, that would be alternative Shift and the down arrow key, perimeter. So Control D means a different thing inside Visual Studio Code. So take note of that. That will be alternative Shift and the down arrow key. That will duplicate the line for you. So here I can now run. Okay. So we have the area and then the perimeter. Now, for a moment, just imagine that you have been given an assignment to write a Python function that calculates the area of circles. And so they want you to make it such that make it look like lists. So you don't have to declare functions, a lot of functions in your file. They want it to be like lists where they can say maybe circle.area, circle.perimeter, circle dot maybe radius or something like that. They want to be able to access all those things using the dot notation. But you search through Python, you find out that there is nothing like circle. You cannot say import like we have been importing CSV maybe, but there's nothing. I don't think there's anything like import circle, which was made specifically for the that geometric shape called circle, where you can say maybe now circle dot area, circle dot perimeter, or anything like that. So in that case, you have to create your own class or your own blueprint, like we have done, which will give you all the functionalities, the flexibility to type all the functionalities that fall under circles. So this is also the second example that we take with classes. In its very basic form with class, now we've learned about class variables. We know about the fields. We know about the importance of the init method, and another one that we did not include in this one, which is the str. And so if there are any questions, I will answer them. But if not, we'll move on to another example, maybe the last one for the day. Okay, so I think I'm at liberty to go ahead and clear everything. Okay, so this one will make it a little bit practical. Maybe go a little bit deep. A class of students. There's nothing in Python where you can say import students and then calculate grade or courses for the students. You have to create your own blueprint. So let's just imagine that we want a class called student. Forget about this autocomplete, which sometimes tries to get ahead of me and maybe confuse you. So let me just pass for now. So what do we need if we want to create a student? We need a student's name to keep things very simple. We need a maybe student ID. So student ID. And then you know that I have to initialize it, so to speak here. So I can say self.name equal to name, self.student ID equal to student ID. And then there are other things also. So this is also another thing I want to introduce you to. Now I will add two more fields here, which are not part of the parameters that we pass when we create our class. So I want to get the self dot enrolled courses. Let's add that one to an empty dictionary for now. So you see that this one here, the enrolled courses was not passed to student ID, but we still have access to it. We still have access to it. So this one too is a field of the class, which we don't require the user to type in when they are creating the class. So we use them by ourselves in the class. So here I can now go ahead and say, let's define the str method. So define, and let this one be, let's return student name, and then we can say self.name. Let me take this suggestion for now. I think it will help me and speed things up. And I don't want the \n here. Okay, so self.student ID. So whenever we print the instance, this is what we will get. Great. And now let's define a method that will enroll students. So I can say define enroll course. I'll pick this one, and then I can now enroll a particular course name, something like that. Sorry about that. I will not give a documentation because our 1 hour is fast approaching. So I know you already know how to do that because of the previous example. So I'll go ahead and then implement the functionality to enroll the students. Now, there are instances where, okay, we can say self dot enrolled courses. Now we have access to it here. And then you know how to add things to a dictionary. You can say course name, or not is it course name. We need something like that. Okay. Maybe I think apart from the course ID, let's take a course and let's take a course ID. I forgot that one. Sorry, a course ID before the course name. So the ID comes here, course ID, and then we set it equal to the no course name. There's no square bracket. So this you are familiar with already. It's just that now it's appearing inside the class. We are just adding the particular course ID as a key and the course name as a value to the enrolled courses dictionary of that particular student. But you know that if we always do this, there will be a disadvantage with this. But let's see now, get a method that will say view enrolled courses or something like that. So then I'll come back to address this particular problem here. There's a problem there. I don't know if you have seen it. So define, maybe get enrolled courses. And then we can say return, should we return it all at once, or maybe we can say for, let's just beautify it. So for ID or for course ID to make it more readable, and then course name in self.enrolled courses. I'm not calling it here. I can say print now. Even before that, but yeah, let's just forgive me. I'm just kind of being low. The particular statement to put there is what is the problem now. So name, and then we can say the ID comes first. Sorry, ID, and then course ID, and then we can give a space and say name, which is now course name. Okay. Is it enrolled courses? Sorry, enrolled courses. Okay, enrolled, not enrolled course. Okay, now our error is gone. So self dot, this will get us all the enrolled courses. Okay, so let's just create an instance. Maybe say student, that should be equal to student. And you know that we have to pass in the name. So let that one be equal to myself, or let me use Bob. And then what do we have to pass in again? The student ID. For now, let's just say 00001 or something like that. If we say students.enroll course, sorry, what is wrong with my typing to the enroll course? We have to pass in now the course ID. Let's say that is math 001, which is a mathematics course. And maybe we can say pre-calculus. Calculus. Calculus. Yes, that is the course name. Now we can say student dot get enrolled courses. Are we printing it or we are returning it? Okay, we are returning it. But let's beautify it here. So we can now give a print statement here that says courses enrolled by, and then here we give self dot name for the course ID. So self dot name. So the courses enrolled by that particular student. We first see that if it is in this case Bob, we should see that courses enrolled by Bob before we see the courses that Bob has enrolled in. So says too many values to unpack. Where is that error coming from? As I said, always when you get an error, the last one is the most important. It says for course name and course ID. Okay, so it says at this particular place in get enrolled courses, is getting too many values to unpack. But that shouldn't be the case. Okay. I know why. we have to pass in dot items. It's a dictionary, so we have to get the key value will give us the item. So I have to pass in items here. I forgot that, sorry. So now we shouldn't get any error. Yep. So now we see courses enrolled by Bob. It is Maths 001 and then pre-calculus. Okay, maybe I should put a bar here so that it separates nicely. Now, let me bring you back to the error I was talking about. Now, let's not enroll Bob. Let's try to get the courses. Process finished with exit code 0, which is good, but not what we were expecting. So you know from what you have done previously that we can first, okay, or even if this one is there, let me just enroll Bob for 4 times in the same course. Now you see, I think it's the dictionary that is trying to maybe do something for us, but if I should change this one to Math 002, let me see. We got what we were looking for, but it looks like our for loop has some. Oh, okay. Sorry, this one should be up. This one should not be here. It can't be for the for loop. Sorry. And so when we run it again, this is it. So I had 4 enrollments here, but I only saw 2. And that is because it uses the key to do that. Fine, because this is a dictionary, probably it has caught it, but think of yourself building a system for a school. You don't want somebody to actually enroll staff in here like this. So we can try and catch that particular error, assuming it is going into a database. I'm not sure this would have been prevented. Almost all of them would have gone in straight ahead. But this dictionary, I think that dot items is what did that for us. But if it is going into a dictionary, this data will go in straight. I'm sure about that. It would have gone in straight, and there will be duplicates in your database, and that is not good. So we can first check if the course is not already, if the student is not already enrolled in that course, then we add it. So you can say if course ID not in self.enrolled courses, so like it is suggesting, so course ID not in self.enrolled courses, that is when we want to add it, not self. But if it is already enrolled, already in it, then we can say else. Maybe print. This course already enrolled, not this one. Let me clear it. I want to give a proper sentence. Self.name is already enrolled in course ID, something like that, because it's the ID that we expect to be unique. Maybe there can be different departments with the same course name, but the course ID will always be different across the entire school. So we can't use the course name to do the check. It's the ID that we'll use. And so when we run it again, I think I'm expecting to see some stuff printed here. So we see here that now it says Bob is already enrolled in Math 001. So that is what I was trying to draw our attention to. And then in here in order to return empty stuff in case the student is not enrolled in anything, let me do the demonstration here. So Bob is not enrolling in any of these, but we are getting enrolled courses. Because of the print statement that we have in there, we see this thing here. But let me go ahead and then comment out that print statement also. Nothing happened. process finished with exit code 0. But you know that it's not so informative, especially if this is a backend for a software for a school. Actually, you don't want to. They have queried for courses enrolled by Bob. They did not see anything on the screen. It doesn't really make sense. It's not user friendly. So we can also here say that if self dot enrolled courses, then do this. Else say print an f string self dot name. Sorry, name is not enrolled in any course. Okay, so let's try it out again and see. Okay, so you see here that Bob is not enrolled in any course. So that makes it more user friendly. And so I'll go ahead and register Bob for the 2. So this is the Math 01 is pre-calculus, and this is calculus with analysis. Okay, so Bob is now enrolled. I want to get another student here. Student 1, maybe that one will be for let's make this one Alice. And then Alice's ID should be 00002. Okay, and then I can say student 1 dot enroll course, not enroll course. Why enroll course? Then the title here is what courses should Alice enroll? Maybe Alice is just trying to combine stuff, so ENGL 001, which is English, grammar, and communication skills. Okay. Where is this? I'm sorry if I can't keep it smaller like this too, because I really want you to see what I'm typing. So forgive me for some of the text missing on the screen. So student 1 dot enroll course, and this course ID will be not English 001 again, but SCI 001, which happens to be plant biodiversity. I don't know whether these courses exist anywhere. I'm just trying to create things out of memory. And so here we can, after getting the courses enrolled by Bob, can put an empty print statement here and then say student 1 dot get enrolled courses. So that is it. Okay, courses enrolled by Bob, courses enrolled by Alice. So you see that with just one blueprint, we have been able to create these things separately. If we are fine, some of the functionalities can use functions, ordinary functions to do them, and use these ones to call and all that. But you know that if we are using functions to do this alone, then there should be a dictionary for Bob separately. There should be a dictionary separately for Alice. But because we are using a class, which is just a blueprint, and even in that case, if we were using functions, we would have created functionalities that are only specific to maybe Bob and Alice only, because the students in the English class, they will be doing different things than the students even in the science class or the math class. So if we are to go ahead and implement further deeper functionalities that each of the courses can have, then we find out that classes come in very, very handy. Instead of just writing functions, trying to map individual students like this to separate dictionaries, that will be just uh, heavy on the machine's computational power. Just a blueprint like a class student, and then we have everything at our disposal. Our time is far, far spent. But let me implement one more functionality, then we can take questions, if any, other than that chapter on today. So define drop course. Maybe you just want to drop a course, drop enrolled course. I will take the course ID here. And then, I have to just implement the check first. So I will take PyCharm suggestion. If course ID in self.enrolled courses, then I will delete this one. And then maybe I can give a message like print. And then self dot name is now unenrolled from, maybe I can, since I'm wrong here, it's unenrolled is not an English word. Even whether it's an English word or not, I'm just trying to use it to say that the student is unenrolled. But forgive me if you're an English person, it's not an English word. Or maybe the student is now not enrolled or something like that, just to be safe. Not enrolled in, and then I can bring in the course name here. So I can say self dot enrolled courses, and I can get the course by the ID. So course ID. So it's not enrolled in that particular course. And then we can come here, and then now let's just hope that after Bob registered the calculus with analysis, he decided to unenroll it. So I can say now student, which is the instance for Bob, dot drop enrolled course, and I pass in the ID, which is math 002. Okay, so now let us run it and see. It says key error. Okay, let's click on this blue link, take us there, and let's see. Key error. Math 002. But that key should exist after this has been created. Let me see again. What can the error be? If course ID in self.enrolled courses, then delete it. That is not a fix, but let me introduce the else statement. In the case where the student is not enrolled in the course at all, we can now say else print, add an F string, self dot name is not enrolled in course with ID, and then we can pass in the ID that we did in the course ID. Let me see. I'm not saying this is the fix, but let me see if it will give us some useful information there. Okay, so that is not it. That is not it. So let me come back here and see. So if course ID in self.enrolled courses, which is a dictionary, then delete it. I don't really understand why this is not working. Let me pass in here like course ID, and let me copy this and paste it here. And let me see. Let me uncomment it, run it again and see. Now we have it. But why are we not able to drop the course? Key error. Okay, where is this? Before we drop the course, let's print student dot enrolled courses. Okay, and then let's see what will appear. So there is the key maths 002 in there, but it's still saying that there's a key error. Wow. Oh, I see. I see. I see. And I think you also probably realized it. That is because this ID, this course is not accessible after this line. After it has been deleted by this line, we don't have access to it in memory again. So now what you are trying to access here in line 30 is something that does not exist. Is that it has been deleted. And so what we can do is to bring this line up rather, because we know that definitely we'll delete it after this line. And then that should fix our error for us. It was not intentional. I must admit it was not intentional, but I'm glad. Sometimes I'm glad when things like that happen on live stream, so that at least you know that um, things like that do happen in the development process. So at least you also see how I try to fix out my errors. Like in this case, I said, okay, fine, let me print the enrolled courses to check because they told me key error, but I'm sure my key exists because I even copied it from the enrolled course, and pasted it. I actually even gave it a named argument also. So I found out that the courses print out carefully. But it was after this step that I realized that I'm also assessing after deleting. So that is also great. So now that it's worked, you know that Bob, where you see, this is Bob's courses that we printed. But now Bob's course is only one here. Yeah. So and Alice's own stays the same. So that is it about the basic functionalities of the student. And that will be the end of our introduction to classes also. If there are no questions, fine. But if there are, I will answer them also live. And then we can close chapter on today. So as always, I'll give 1 minute if there are any questions I have to address. Other than that, we can close chapter on today and anticipate for tomorrow. Okay, I suppose that there are no questions, but if there are still questions, you know that you have to put it on the common platform, or if you are watching this stream afterwards, you can put it in the comments and I'll come and answer. So thank you very much for your time today. I hope you enjoyed today's session as well. And until tomorrow, it is goodbye.